Welcome to qnawire.
Let's talk about this question. It says that a horizontal wire holds a solid uniform mass, a ball of mass m. So this is a mass m. This is a mass m, and tilted at a ramp that rises 35 degrees above the horizontal. The surface of this ramp is perfectly smooth. It means that there is no friction, and the wire is directed away from the center of the ball as shown. So we have to draw a free body diagram. That's one. So for the free body diagram, in fact, let's try to make it over here. We first have a tension due to the string. Then we have a normal reaction. Remember, the normal reaction will be normal to the surface. So that's gonna be directed somewhere here, and let's represent it by the normal reaction is in. And the another force is gonna be the weight. So weight is gonna be exactly downwards at a 90-degree angle. So let's represent it by the weight W. So this is the required free body diagram representing all the forces over here. So let's mark it A. Then we move towards part B. So part B talks about we need to find the surface. How does the surface push the ram? So we need to find the value of normal reaction because that is the force by which the surface pushes the ram. So for that we need to make the components of the forces along and perpendicular to the plane. So normal is already perpendicular to the plane, but for tension and for the weight, we need to definitely do some calculation and make the components. So let's talk about the tension. The tension is somewhat like this, and this is the angle which is already given as 35 degrees. So its component along the surface will be T cosine 35 degrees, and perpendicular to the surface is going to be T sine 35 degrees. Likewise, for the weight which is acting like this, and this is 35, this is 90. So it will have a component, one is towards this and one is like this. So this angle is also 35 degrees as per the geometry, because this is 90, this is 35. So this is 90 minus 35, so this is again 35. So this is gonna be W cos 35 degrees, and along the surface is going to be W sine 35 degrees. So let me just redraw this with a clean in a clean fashion. So if this is the ramp, then the forces are perpendicular. There is a normal reaction, and that's the only force in this direction. Then exactly opposite, we have this force, which is T sine 35 plus W cos 35. Over here we have one force which is T cos 35, and over here as well we have one force which is W sine 35. So this is how the complete forces looks like. We need to find that the value of normal reaction. So definitely it is at rest. So we are going to equate the forces in all the directions. So N is equal to T sine 35 plus W cos 35. And let's call this equation 1. And T cos 35 is equal to W sine 35. So from here, from equation 2, we can substitute the value of T in equation 1. So equation 1 looks like T is replaced by W sine 35 over cos 35 times sine 35 plus W cos 35. So this is going to look like, if we take this can be written as W tan 35 times sine 35 plus W cos 35. Now, are we given the value of mass? No. So we are going to replace W by mg at last. So W can be taken out, and the rest of the terms can be simplified using a calculator. So let me grab mine. We have tan 35 times sine 35 plus cos 35. So that's going to be 1.22, and W is replaced by mg. So we are going to write 1.22 mg. That is the required normal reaction, which is the answer to part B. And part C talks about the tension. So tension can be easily found now from the equation 2. So the tension is nothing but W sine 35 over cos 35. So in short, we need to find the value of tan 35. So tan 35 is 0.7. So we have the answer as 0.7 and W is replaced by mg. So this is the required value of tension in terms of m. Thank you.